Well, I'd like to welcome you all to the QFE at the Stern School. This is the last QFE of the term. We'll be starting up again, I guess. I'm not quite sure what the schedule is in the spring, but anyway, it'll be the same sort of arrangement. Today, we're very fortunate to have with us Gernot Wagner, who is in the Department of Environmental Studies at the Wagner School at NYU. So he's one of our own. He's on our faculty advisory board and has the distinction which many of us would yearn for of being invited to be a columnist for Bloomberg Green. He writes a column called Risky Climate. He's given TED Talks. He's got a couple of books out, one with on called Climate Shock with Marty Weitzman, and a very influential article with Daniel and Litterman in the Proceedings of the National Academy of Sciences, which we actually had Bob talk to us about a couple of years ago. So it's really terrific to have you with us today. And why don't you tell us what we need to know?
Yes. So thank you, Thorpe, for this generous introduction. It's great to be here. Yeah, what I would like to do today is, I guess, sort of twofold. So yes, there's an article here in the background, which went out through the listserv. So most of you might have seen this. I will, in fact, spend most of the time talking about this paper. What I would like to do first is just give a sort of a very high level orientation of where all of this fits in the conversation around social cost of carbon, social cost of CO2, carbon pricing, and so on. And maybe to just pick up where Rob left off with his generous introduction. So I have written a handful of papers and a book on this topic. And this paper, in some sense, is my very first time in my life that I'm sort of going back to something and more or less correcting myself. And basically figuring out that, well, maybe there was something fundamentally flawed the first time around when I looked at this. Maybe the answer is not quite as simple as a simple Bloomberg column might suggest, let's say. So there is a little bit of history here, and that's exactly the biggest reason why I'd like to go through some of the history of the social cost of carbon here as well. So where does this overall topic of carbon pricing fit in the current policy world, the current climate finance world? So here's sort of, I won't give this as a pop quiz, but when someone says social cost of carbon, the one number that often sticks in people's minds is this $40 per ton of CO2 figure given to us through basically the Obama administration. So it's a couple administrations ago at this point. It was a major process, 12 government agencies, 3 climate economic models, Mr. Benefit Cost Analysis himself leading the process. Lots of folks involved in this process whose names we would all recognize. Larry Summers, Bill Nordhaus was engaged, lots of others. And what came out of this process was technically a technical support document to a filing of the Department of Energy for energy efficiency standards for walk-in refrigerators. That was the prompt. That gave us this major interagency process that led to this roughly $40 per ton of CO2 social cost of carbon. The last 4 years, current 4 years, we have a social cost of carbon figure that is about 1/10 of that value, right? So that alone tells you the politics of it all. And of course, right, if the social cost is lower, there are lots and lots of rules that you would not pass, or for that matter, rules you would want to remove, withdraw from. So yes, this number matters. It matters a lot. There is a lot of uncertainty. Just this, table 1 here alone basically tells you that the discount rate matters. It matters a lot, right? The right column, uncertainty matters. It matters a lot. The 95th percentile of the distribution, right? Not the value we should take as the average, the mean, the median, but one of the values that is clearly within the potential distribution here, well, that is over $100 as we speak. The difference, by the way, between $40 and $100+, again, to give us a sense of what this all means, $40 is the ExxonMobil supported carbon tax. Just to mention one pariah here, right? Lots of other companies, of course, involved in that too, right? Sort of these bipartisan carbon tax proposals, somewhere around $40, all anchored in many ways on this social cost figure from the first, second Obama terms. $100, $100+. Well, now we are sort of in, not quite Green New Deal territory, but obviously much, much more ambitious climate policy. What I would like to do now, just briefly, again, sort of as a history here, introduction in some sense, is to argue that this number, of course, or this number, not of course, but in fact, ought to be at least $100. I can't give you the exact number, right? There's no single right number, not even in theory. There's a distribution, but there are lots and lots of reasons why that number should be higher than $100 per ton of CO2. So one, and this is not my own work, there is, example, the Climate Impacts Lab, Michael Greenstone, who himself was involved in the social cost process in the Obama administration, Saul Shung at Berkeley, Bob Kopp at Rutgers, lots of others are working on these major efforts trying to quantify the quantifiables, climate damages that we know exist, we just in some sense haven't gotten around to actually quantify them. So that's one major bit of research. That work ought to include, does not at the moment, it ought to include tipping points, right? So that happens to be something I've been involved in the last couple of years. So major review of the potential tipping points that have already been quantified in the literature. Huge range, a large distribution. Here, this plots the percentage increase in the social cost of carbon, depending on which calibration and which tipping points one might include. That increase is somewhere between 25%, 27%, 43%, of course, false precision here, right? So let's call it 25 to 50%. That's one is the mean, the other one, sorry, one is the median value, the other one is the mean value. And yes, there's a large distribution here too, simply in the percentage increase of the social cost of carbon. Okay, so that's still the first bullet. Then there is tail risk. So all the credit here goes to the late Marty Weitzman, who spent a lot of time, basically the last decade of his life, writing several papers on this topic. I was lucky enough to write a book with him about this. And the topic, or the point here, going back to a distribution, something that looks like this distribution here, is that there too, we have a very right-skewed distribution. And while the most likely value might be what we all calculate, are able to calculate, focus on, let's say a 3-degree climate sensitivity calibration or estimate that translates a doubling of CO2 in the atmosphere to 3 degrees global average increase in temperatures. That's the most likely value. It still is to this day. But yes, there is a large distribution around that value. Okay, that's 0.2, and yet another reason why the social cost might increase by quite a bit over this $40 estimate. Discounting, of course, matters a lot. Lots of good arguments for declining discount rate to be applied here that starts at relatively high today, declines very, very quickly. Lots of good arguments, something like 600 papers in the peer-reviewed literature in the first decade of this century on just this topic, largely prompted by the Stern Review on Climate Change, which when Bill Nordhaus was still calculating around $20 per ton of CO2, Nick Stern got over $80, the difference, discount. Lots of important questions around this, and actually already a lead into this last topic of the last reason, which is what, loosely speaking, what I might call a proper preference calibration. For those in the know, Epstein-Zinn utility functions, which the biggest takeaway there on a very high level is this is not about picking the right discount rate. We in fact ought to be calibrating that discount rate. Rob mentioned before, Bob Litterman presented our paper a couple of years ago in the seminar. So there's the sort of the 80-page NBER version. There's the 6-page PNAS version of this. And frankly, the sort of the biggest takeaway from this is if one takes this asset pricing framework seriously, and if one basically begins from scratch with one of these climate economic models, treating CO2 as an asset with negative payoff, Epstein-Zinn utility, maybe lots of things we think we know about pricing climate risk actually get turned on their head. Most prominently, perhaps, maybe the social cost of carbon price path shouldn't start low and increase over time. Maybe it should even start high and over decades, centuries, decrease over time. A number of reasons for that. Risk and uncertainty, of course, play a prominent one. Okay, so there's this laundry list of reasons.
Yeah, could I ask you a question?
Of course, yeah.
I've been wondering about.
Back to this.
This discussion about discount rates, it was somewhere between some kind of a social measure based on preferences and a market rate. Well, now that market rates have come to such a low level, and they're actually, everybody's forecast is that there's no real reason why we can even expect them to go back up again to what we've thought we have seen traditionally. I wondered if this topic has become less prominent.
Sorry, yes, in some sense, let me put it this way, has it become less prominent? No, not at all. It is still, right, sort of in the climate economic world, and in some sense, this shows one of the bigger disconnects here. It really does. So in the climate economic world, Ramsey discounting is more often than not the way to go, right? You don't read that off the 30-year risk-free rate, right? You stipulate what the discount rate ought to be. Bill Nordhaus still, right, to this day, right, his preferred discount rate is 4.25%, and it decreases over time to like 4%, right, barely. It is incredibly high. And, right, this is in many ways, so I'm a climate economist, right? The financial economists looking at climate economics would say, wait a second, like you're not getting it here, right? You're doing this completely right. So you can't read off the risk-free rate, right? It's given to us. There's a website, right? So read it off. And that's close to zero, right? Or whatever, it might be very, very low, right? Lower than 4%.
It's way lower than your graph. It didn't go down to 1%, whatever, which kind of where the relatively long rates are now.
Exactly, right? So in some sense, well, so implicitly, so behind this graph here, we in fact have so the implicit discount rate is something like 2+%, right? So it's about half of the Bill Nordhaus dice assumed discount rate. It's not as low as discount rates are now, right? It's not. And yes, right, it makes a huge difference to the social cost. In fact, actually, this is a completely different set of analyses, but Germany. So I'm Austrian originally, so I can make fun of the Germans here. They use in their equivalent of this Obama era technical commission, basically estimating the social cost for the country. They use the social cost in completely different ways, to be clear. But their estimate of the social cost ranges from 200 euros to over 650 euros. Why? 650 assumes a 0% pure rate of time preference, right? They're still in the Ramsey discounting framework here, but they have a 0% discount rate, a very, very low discount rate. And the social cost is in the hundreds, right? In many ways, justifying many of the interventions happening in Germany, like solar feed-in tariffs and so on, that have an implied social cost of $600, $800 per ton of CO2. So yes, right, excellent question. To the narrow question you asked, did this topic go away as a result? Not at all. If anything, it is even more prominent because now, right, this is now sort of climate economists sort of feel full on, assault here, right, from the financial economists who I would say have a point, right? This paper, the graph I'm pointing at here, you're all looking at, is in fact this collaboration of two financial economists with one climate economist. And, the origin in some ways was my complete and utter failure trying to explain DICE, Bill Nordhaus's DICE model, to my two co-authors here, Kent Daniel and Bob Litterman. Right? This was literally one of these where, they're both stellar financial economists. I'm not, right? I'm a climate economist. So I tried to explain DICE, which to me, this sort of, that model made perfect sense. It has all the standard heuristics we want to include. It is a very simple framework and so on. I was completely unable. I completely failed trying to explain this model to Bob Litterman and Kent Daniel. Right? And discounting is a prominent reason, is an important reason for that. I see we have a question here from Dick related to Ross' question. What are the analytics behind the choice of, say, a 4.25% discount rate? Great question. Let me, knowing that Bill Nordhaus isn't here and can't defend himself, I think I'm pretty sure he's not here. But if he is, that would be, I need to watch what I'm saying now. But so in some sense, this is calibrated, as it were, based on what Bill Nordhaus, others, basically call the quote unquote opportunity cost argument, right? So the economy grows at a rate of, fill in the percent. So if you have $1 or $1 billion and you choose where to invest it in, you could either get this rate of average rate of return when investing your money in the economy, in the broad basket of goods and services, or you could invest it in climate mitigation, and the return you get for investing it in the economy is this 4+%, right? Technically, that's supposed to be even higher. So this is sort of the lower bound of what's possibly justifiable here. And again, right, even now, me saying this out loud now after having worked with Bob Litterman and Kent Daniel for a few years, that argument basically makes no sense. That's not how you justify investment. It's not about the average return. It's about risk as well. Not just about the average return, it's about risk as well. So on. Bill Nordhaus, to his full credit, in his documentation of his DICE model by now includes several references. One footnote explicitly mentioning Epstein's Inn, for example. Well, he does that, and then he basically says, and by the way, that's a live topic of research. I will now ignore this. I will go forward with what I've always done. So honestly, if you asked me to say this in a pithy sentence, I would say there really is no justification for that 4.25% discount rate. That said, for climate economists writ large, well, Bill Nordhaus shared the Nobel Prize on this topic, right? This is something that is sort of a standard view of the world, our side of the aisle.
There
Bob,
is also a comment in the chat, which I think is helpful, that to translate the cost of carbon into the price of a gallon of gasoline, you basically divide by, what is it, 100 or something like that. So
actually, yes, right. So to give a sort of, actually, yes, to give a sense of what it means, right? $100 per ton of CO2 is roughly like 95 cents per gallon at the pump, right? So $40 per ton is some like 35 cents per gallon at the pump. So 100 is like, 90 cents or so, 92 cents per gallon at the pump, right? Which actually, depending on your perspective, right? Well, $40 as in 35 cents per gallon, that's less than the difference between Memorial and Labor Day, right? That's very little. And not to be too overly political here, but actually one of my recent Bloomberg columns that got quite a bit of traction, I can say here, I can tell you, was this basically, it was called something like the Exxon Tax, right? So $40 per ton of CO2 just isn't enough. Why? Well, just look at why Exxon supports it, right? One reason is 35 cents per gallon doesn't do much to our driving behavior. Meanwhile, Exxon is half oil, half natural gas. On the natural gas side, $40 per ton prices coal out of the electricity system once and for all, making natural gas profitable, frankly, for the very first time ever. Right? Exxon just wrote off some like $20 billion of the natural gas investments in fourth quarter. Right, it may actually be in the narrow quarterly business interest of Exxon Mobil to be advocating for a $40 per ton of CO2 carbon tax. Whereas $100, right, a buck a gallon, yeah, that makes a difference, right? Suddenly, the complaining gets louder, right, on the one hand, and the lobbying gets more intense. And of course, right, you could imagine that influences decisions of whether to pack up and leave Manhattan and move out to the burbs, let's say, right? If you know that you have to drive back and gasoline is now a dollar more expensive. Sorry. I'll do it. Perfect. Okay, sorry. Homeschooling while home office. Okay. Moving on, unless there are any more questions on this. So right back to sort of the overview of lots of good reasons why the social cost is at least the $100. And again, this might be in some ways considered a cop-out answer here. In some sense, it is. I couldn't tell you what the right answer is. So in this Bob Litterman, the Ken Daniel paper, we go through pains not to actually provide the actual dollar estimate in the text. So of course you can read it off the graph. So guess what journalists do, right? They take their ruler out, right? Measure it, and then they call you up. Can you confirm that your social cost is $124.8, right? To which the answer is, well, no, I won't, but good job. Yes, that's what we have in our graphs, right? Okay, so yeah, that's the slew of reasons why the social cost ought to be a lot higher than the $100, right? Okay, so moving on to this paper, what I'm supposed to be talking about. So there are basically these lots of reasons why, for example, the simple tails argument, the fat tails argument, is not quite as simple as meets the eye. What I call here the Rowe-Bauman time component. So this is a climate scientist, Mr. Rowe, at the University of Washington, and Bauman, who actually, Yoram Bauman, he calls himself the stand-up economist. So some of you might know him from, well, his stand-up routines involving Economics 101, 102. He is, in fact, incredibly funny. This is a serious paper. What his critique, in some sense, does is say, sure, there are tails, but the longer the tail, the longer it takes to get there. Suddenly time matters. It matters a lot. And then, of course, yet again, discounting coming to the fore here, where the longer, right, the longer the time horizon, the more discounting matters, and suddenly the interaction of those two might matter a lot. Suddenly it's a race between the tail component, the tail risk, tail uncertainty, tipping points, if you will, and discounting. Okay, so to dive a bit more deeply into the first critique, the fat tails argument. I mentioned climate sensitivity before. Just sort of in this long chain in this climate economic chain from economic activity, emissions translated into concentrations of CO2, concentrations into temperatures, temperatures into damages, damages into monetary damages, then feeding back into GDP. Right, this sort of long chain, lots of uncertainties every step along the way. The largest uncertainty, and that's saying something because everything else is uncertain too, but the largest uncertainty might be, it has been for a long time, translating concentrations of CO2 in the atmosphere into global average temperatures. There is a specific parameter that's not particularly new. Svante Arrhenius calculated it for the first time in 1896. So this stuff is, right, this is old, so 2 centuries ago at this point, 125 years ago. He calculated this parameter based on a doubling of CO2 in the atmosphere. So a doubling of CO2 in the atmosphere linked to global average eventual, every one of these parameters matters, global average temperature increases eventually due to this doubling. That parameter has a tight definition. It's called climate sensitivity. It has been persistently uncertain for decades. That is this infamous National Academies review from 1979. There were basically 2 studies out there at the time. One said 2 degrees, the other one said 4 degrees. The commission at the time added half a degree centigrade because why not? There's uncertainty, and they called the range 1.5 to 4.5 degrees. That was the quote unquote likely range, not a very tight definition of what that means, but that was the range of this climate sensitivity parameter in 1979. Right, by now we've had 5 major IPCC assessment reports. There was one report in between where this range narrowed. The lower bound got increased from 1.5 to 2 degrees. By now we have a much better definition of what it means to be likely. It's defined to be 66% likely, not 2/3, not 67. Please don't ask why. 66% probability to be between 1.5 and 4.5. This past summer, was a major review sort of outside this formal IPCC process, but a major review of the climate science here, climate scientists revisiting this number. What we got was basically the same that the IPCC did a report ago, increase the lower bound, decrease the upper bound ever so slightly, but not by all that much. And then under certain specifications, the upper bound went right back up to where it used to be. So it's reasonable to say that the 1.5 to 4.5 degree likely range is going to narrow in the near future in these formal IPCC assessments. It's not going to narrow the right way, as in the lower bound is going to increase. Right, increasing the average, the mean, the median, and of course, skewing the distribution even further. Okay, what's the critique? What's the Rowe-Bauman critique? And while I do this, sun hitting my face, sorry. Set this up here for, there we go, sorry. So what we see in sort of a very loose sense is the further out we go, the more discounting matters again. And the larger this climate sensitivity distribution is, that's the main graph here on the right, the increase in years is rapid, is enormous, right? So this is not just saying that, it's climate sensitivity distribution from, let's say, increase from the mean value of 3 degrees centigrade global average warming due to a doubling of CO2 versus 3.5, right? Increases by a certain percentage. No, it's exponential. It's logistic, right? This increase is fast and it matters. Or put differently, again, this sticking with the Rowe-Bauman critique here, right? And this is their language now. I wish I came up with this myself. Even for a planet that is formally headed toward oblivion, it can take a very long time to get there, right? Or in other words, yes, this fat tails argument matters. It does matter a lot. But if you go to the formal distribution of climate sensitivity, it is defined as what happens in the limit, infinity, right? Infinitely many years of getting there. And equally important, the tail, the 6 degree, the 7 degree, the 8 degree, the massive increases that truly drive these tail risk arguments, sort of the core of my argument with Marty Weitzman in climate shock. It takes thousands, tens of thousands of years to get there, for the planet to get there, which doesn't mean it doesn't matter, right? It's so in some sense, ethically, philosophically, right? It might matter even more, right? Because basically we are saying the actions of us now as a society, the next 10, 20, 30 years or so, will define the future of the planet for millennia. In some sense, we've always known this, but right, this is even more now core of this argument here. But as economists who do worry about discounting, who do worry about the time component, we can't just wave our hands and say fat tails. We have to include this time component too. Okay, maybe just one more quick bit on this. The history of this paper is actually fascinating here, this Rowe-Bauman paper itself. Rowe is the climate scientist, so the two of them tried to publish this in the climate science literature first, and basically the response was, wait a second, we all know this. This is so simple. Like, this is, why bother, right? Like this, of course we knew that time matters. This is not worthy of publication here. While on the econ side, around that time, there was this argument between Marty Weitzman and Bill Nordhaus on tails versus means and so on, happening right on the pages of AER and JEL and so on. Well, this paper in many ways was considered to be too technical, too out there, not really contributing much to that particular literature. Okay, so it obviously was published, ended up in Climatic Change, which is sort of the halfway house here, maybe the appropriate place to begin with. But still, even that history matters, right? It's such an obvious point to the climate scientists. To the economists, it's basically, well, new, novel, something that doesn't show up in our thinking on this at all. And I checked Google Scholar a couple of days ago on this. So it basically got cited something like 6 times total. 4 of them is me. So, right, it's sort of, which is another way of saying, right, it was completely ignored at this paper. The climate scientists think it's trivial. We don't quite know what to do with it as economists. Okay, the point of this exercise here, of course, now is to try to make sense of this. So what we came up with, I should say my co-author here is Bill Hogan, energy economist at the Kennedy School. So what we started doing here was try to find the simplest possible way to integrate both of these questions, this Rowe-Bauman specification and Epstein's into a model that climate economists would understand. I can also say, despite now having spent several years, arguing how DICE is not the way to go and we ought to move beyond. It is, of course, a very, very useful framework to guide our thinking here, largely because it is a very simple model that every climate economist has played around with themselves at some point, that everyone more or less understands what's going on. It's 20 equations, 3 of them for the climate system. So you know what the emphasis is, right, on the economy in this case. But it's 20 equations. A version of it runs in Excel. It is very easy to work with. It's very logical. Every grad student has futzed around with it, guilty as charged. So yes, we went back to this standard DICE framework and basically modified it in 2 ways to try to answer these questions. Does this time critique, this Rowe-Bauman critique matter? Does Epstein-Zinn matter? And in some sense, how much does it matter, right? Does moving from log preferences, constant relative risk aversion preferences to Epstein-Zinn, in fact, in our very simple framework, make an actual material difference to the social cost of carbon? And then, of course, what happens when you combine these two? So yes, we built DICE EZRB. That's what we call it, at least. So it always doesn't run in Excel. We use the GANS version of DICE, so right, ancient programming language, but us climate economists, in fact, are futzing around with this still to this day. That's the version we built. We tried to find the simplest possible calibrations to allow us to solve this recursive problem, Epstein-Zinn preferences. So for example, this climate sensitivity distribution, equilibrium climate sensitivity, ECS, we did not try to use the full distribution. We did a very rough calibration. We looked at ECS uncertainty resolving itself basically within half a century, within 50 years. So given that this is already a few years old, now 2065 is when this uncertainty disappears. How do we represent the uncertainty? We put probability mass to 5 different levels, 5 different values, 2, 0.5, 3.5 degrees centigrade, 6 degrees, 8 degrees, and then out there in the tail, right, tiny probability of 16-degree climate sensitivity. Of course, that is truly an extreme value, but, well, it allows for a very, very skewed distribution. Okay, taking this as the input, again, simple representation, runs on my laptop, right? Nothing fancy computationally here. We now tried to probe what happens to the social cost of carbon. And again, right, so this is unlike the Bob Litterman, Kent Daniel paper from before, right? So standard price path starts low today, increases over time, nothing else much happening here. But now we have these 5 different potential climate sensitivity values. We assume that in 2065, we know precisely which value it will be, right? We know the draw from the distribution. We only have these 5 choices. By the way, before I said, right, the choices were 2.5 and 3.5. Turns out to be 2.43 and 3.67, right? So to conform with the distribution here. There is a base case. That's Bill Nordhaus's number, the 3.1 degree centigrade. That's the dotted line here on the left, right? And what we do at first, the left graph here, is we basically just rerun DICE. Now with this at first uncertain climate sensitivity distribution resolved in 2065, we follow the price path. And yes, of course, no surprise, climate sensitivity happens to be extremely high. The social cost of carbon is going to be extremely high. right? Starting that year, 2065, when we draw. Right now, well, we use the average of the distribution. So yes, ever so slightly higher than the 3.1 degree base case between now and 2065. Not all that much higher, but still. Okay. The right-hand side of this graph includes the time dynamics. Right? What does that mean? Well, it means we don't just naively increase the social cost of carbon, the climate sensitivity distribution from 3.1 to 16.15 or to any of these other values. We don't just naively change it. We include the fact that now it takes a lot longer for the climate system to actually reach these values. Everything else remains the same. Discount rate is the same. Inappropriately high discount rate, if you will. What happens? Well, the tail of the distribution no longer matters at all, frankly. Right? The two collapse between now and 2065 and expectations. The two lines just collapse to exactly the same, almost. Beyond 2065, the difference barely matters. The difference between a climate sensitivity of 16 versus one of 8 versus one of 6 basically doesn't matter at all. Those three true tails, draws from the tail of the distribution, collapse to one and the same. It simply doesn't matter. Time discounting dwarfs all else. Right? Simple question, a very simple and frankly very clear answer that if us climate economists did not just worry about the climate sensitivity distribution, but also included the time component that seems so trivial to climate scientists as to not even merit this particular publication, for example, then the conclusion is very different from the standard view, not that standard view, but sort of the Marty Weitzman tail view, how the tail uncertainty dwarfs all else. Time component in the standard DICE model with inappropriately high discount rates, the time component basically removes the tail conclusions or negates these tail conclusions. Okay, second step, Epstein's in. Right, so one potential path to take this from here now is to then say, okay, let's just use lower discount rates and see what happens. Right, in some sense, we did that. Not all that interesting, right? Of course, right? The lower the discount rate, the more these tails suddenly begin to matter again. So instead, what we do is to shift from constant relative risk aversion utility function, log utility, to Epstein's in preferences. Same view here in some sense, just shifting from log utility to Epstein's in on the left, log utility to Epstein's in on the one hand, plus the Rowe-Bauman time dynamics on the other, on the right here. I guess what I'm asking you to do here now is simply squint at the graphs and sort of tell me what you think the conclusion is. But what it is to me is, it's in the blue box down here, the switch to Epstein's in appears to have a much larger impact than the tail dynamics or the time dynamics on top of the tail dynamics for that matter. Right, so instead, this is one of the bullet points I started this hour with. Instead, what happens, instead of using the relative risk aversion, that's just going to a quote unquote proper preference calibration to Epstein's in preferences, that initial value of below $40 suddenly jumps to over $100. 130-ish on the left-hand side without the time dynamics, 110 or so-ish on the right side with the time dynamics. In either case, that jump is large. And it defines the difference here, right? So, pick and choose your battles here. There's only so much you can do in modifying dice in this case all at once. If you had to choose what to do, yes, the time dynamics do matter. The tail story matters. Wrote a book about it. Of course, I think it matters. But at the end of the day, the Epstein-Zinn preference switch matters a lot more. Okay, which right may well be already a satisfying point to stop, at least for me personally, in the sense of saying, oh, cool. So, told you so. Let's not use the standard dice formulation. Let's switch to, for example, the easy climate model that Bob Litterman, Ken Daniel, and I came up with, right? So there's an alternative. It's simple to use. It doesn't run in GAMS. You need Python, modern programming language, so it should actually be an advantage here, and so on and so forth. Let's just be done with this. Well, in some sense, not so fast. And let me just put it this way. I'm going a little bit out on a limb here with this. And this, in fact, is my last slide, or second to last graph here. So I'd like to spend quite a bit of time on this. But the not so fast component here is essentially what I would argue the switch to Epstein-Zinn preferences does is simply push the ethical, the calibration question further back to add some mathematical sophistication on top that is not a surprise to most climate to most financial economists, and I don't know what a stand-in is on this call, right? But of course, right, there's some of us who have a lot of reason to be using these preferences, a lot of good reasons to be using these preferences. On the climate economic side, where there are so many ethical choices to make to begin with, to picking the right discount rate, quote unquote, is only one of many that are crucial in driving the outcome here. Well, what did we just do, in a sense? What we just did is we made the choice of the EIS or IES, or whichever term we use for this parameter, elasticity of intertemporal substitution. We made that the most crucial input in the social cost of carbon calibration. Right? And I can tell you, right, implicitly, I think most of us applying Epstein-Zinn preferences very much understand that. I can also tell you that, right, so Bob Litterman, Kent Daniel, and I weren't the only ones who introduced Epstein-Zinn preferences in the climate economic models by a long shot. There's a dozen, at least, other papers out there that do just that. What's never quite explicit in any of these papers, including my own, including the PNS paper, is how much it truly matters. How much small changes, very small changes, relatively speaking, in the EIS drive the social cost of carbon. So if you look at the table here, right, so the only difference between the top and the bottom is the EIS. One is 0.69, 0.7. The other one is 1.5. This, of course, is now where I'm, in some sense, completely outside my expertise. I've never tried to calibrate the EIS myself based on anything. I somewhat fluent in the literature out there, but I trust that many of you here on this call are much, much closer to the actual literature here than I am. My reading is that we just don't know which of these two is the quote-unquote correct number. Lots of good reasons for one, lots of good reasons for the other. You go to some calibration based on data of the Nordics, the red Scandinavian countries, and you get a certain number. You do the exact same thing for the US, and you get a completely different, or you get a, not completely different, you get a different number. And it is extremely difficult to justify one choice and only one choice. Meanwhile, look at the outcome, the social cost of carbon. Right? Before I made a big deal out of the difference between $40 and $100. One is the one Exxon wants, the carbon tax that Exxon wants. The other one is sort of Green New Deal territory, right? Or close to, right? Biden plan territory. The social cost of carbon difference between 40 and 100 makes a huge difference. Well, everything the same, right? Nothing changed, no different climate damages, nothing better in one or the other model other than a different EIS. One is 0.7, the other one is 1.5. Social cost increases, in our case here, from something like $26, less than $30, with the Rowe-Bauman specification, to over $100. The time component still makes a difference too, right? So no time component, the fact that the longer the tail, the more the time component matters. That's the difference between $26 and $38 here, the left column in the table on the top, and 123 versus 200 on the bottom. That difference matters too. Absolutely, it does. I would argue not as much as this initial jump from something close to $40 to something above $100. The difference, the sole difference, is the EIS.
We have a couple of questions that I think would be good to get your ideas on at this point.
Okay. I'm looking at the chat, or yes, chat here. Go.
Yeah, there's one in the chat from Ahmed Karagozoglu. I don't know whether you, Ahmed, do you want to just ask your question?
Go ahead.
You're still muted.
Gernot, I just wanted to play on the word dice.
Mm-hmm.
Aren't we rolling the dice by pushing the resolution of climate uncertainty further into the future, so that the policymakers will say, oh, that's too far into the future for us to act because of political reasons or elections?
Oh, you mean, so in our little model, we have it in 2065, for example. So, yeah. Okay, short answer, yes. The slightly longer one is, this is the bane of my existence, I can tell you, right? So, just to give you one sort of silly sounding example now, but I spend too much time on Twitter, turns out. That's the one thing you can do very easily while homeschooling your kids, turns out. Right, on Twitter, yeah, or Twitter being the stand-in for sort of these pithy rapid fire sort of backs and forth, right? Not just with the trolls, right, but sort of proper, hey, let's see what actually comes out here. Well, one thing that comes out, not just on Twitter, but it's, in the real world, is yes, if you emphasize uncertainty, which this does, the typical immediate reaction is to say, oh, gotta wait and see. Yeah. Which of course, Ahmed, is exactly your point, right? Okay. Honestly, I don't have a good answer here, but my answer, at least, is to not talk about uncertainty. I call it risk. Which, to be clear, right? So, just to be clear, yes, I have a PhD in economics. I read Frank Knight's 1927 University of Chicago PhD dissertation. I know the difference between Knightian risk and Knightian uncertainty. I try to be good about the different distinction in my academic writing and so on and so forth. But again, on both on Twitter and sort of when speaking in English, or German accented English, but nonetheless, when I say it out loud, I don't say uncertainty when I can help it. I say risk. Why? Because the immediate implication when you say risk to someone is, oh, risk. We got to manage that. Insurance. We need to mitigate. We know what to do with risk. We take out insurance. We mitigate risk, which of course in the climate world, right, mitigating risk has a very clear, clean implication of mitigating CO2. And, yes, good job, buddy. That's it, right? You got it. We have to cut CO2 emissions. That's it. The more the risk, the greater the need to cut CO2 emissions now, right? Meanwhile, yeah, when I say uncertainty, often the response is, oh, uncertain. more work, need to study more, right? And again, this is not not just on Twitter now, right? But sort of the George W. Bush administration, right? Same thing. Actually, they employed Frank Luntz, right, to run the focus groups in Scranton, right, to figure out whether to call it climate change or global warming on the one hand, and of course also whether to call it risk or uncertainty, and to emphasize the uncertainty as a reason to delay. So, excellent question. And in some sense, right, I'd like to think that this is sort of the safe space, right? This is the place where I can properly talk about uncertainty without having to pretend that risk and uncertainty are both the same. I can make the distinction. And what it shows, right, is that emphasizing uncertainty properly does increase the social cost of carbon, which does increase the need to cut CO2 emissions, even though, as you picked up on appropriately, is when you say that out loud, out there in the real world, the immediate reaction is, oh, the science is uncertain. We can't do enough yet. We need to study more. We need to, then now we're sort of in, cigarettes, right? Marlboro world, right? Where cigarette companies for decades, right, were arguing we just don't know whether cigarettes cause cancer, right? Whether smoking causes cancer. We need to study this issue more. Well, that's where we've been for decades at this point. So yeah, great question. Not a very satisfying answer, I believe, but that's sort of
just confirmed that words matter.
Words matter, absolutely. Yes, they do. And sorry, Rob, there was a second question you wanted me to address?
Okay, so a second question was from Larry White, who wanted to know, how do you do all this with tipping points?
Oh, great question. Let me just switch to the slide from before. And to be clear, actually, I hope my three co-authors on this paper are not currently on the call, because I currently owe them something major on that paper. We're supposed to be submitting it today or this week, and it's up to me now. So I hope they're not on this right now, listening to me that I spent more time on Twitter than doing proper work, apparently. But what we did here, or what I think is sort of the way to think about tipping points, is there is sort of a collection of half a dozen or so, many potential climate economic tipping points, major ones, right? The West Antarctic ice sheet, disintegrating, collapsing, and sea level suddenly rise by 10 to plus meters. Amazon dieback, ocean methane hydrates, right? Sort of methane bubbling up and causing rapid warming immediately, right? And there's sort of the Gulf Stream stopping, turning around, Europe freezing over, right? Turns out that goes the other way, right? Cooling in Europe, but that's another major one. So we go through this list of tipping points from the climate literature on the one hand, right? And sort of have our laundry list. And then we review the 40 or so studies by now in the climate economic literature that for the most part basically pick one of these tipping points, try to calibrate it, integrate it into DICE or another climate economic model, and then try to see what comes out. So what we do here, we call it a meta-analytic model, right? So it's not just a review of the literature where we pick somebody else's numbers and that's it. We create our own model that allows for integrating all these different tipping points. And then it allows us to do things like, right, turn them on and off individually, look at the interactions, look at lots of implications of that. And for example, focus on the relative change in these tipping points, right? So as you can see from this graph, right, we go through pains there too, not to give you the absolute value, right? But to basically just look at the relative change. Well, when we do that, and we go through all of them, sort of the 8, I believe, major tipping points in this case that we've quantified here, we get to, frankly, a wide distribution of that increase in the social cost of carbon relative to the scenario without tipping points, without these extreme events, right? Now we can argue whether tipping points, in fact, is the same as talking about tails. In many ways, it is not, right? There's a different flavor here. The tail of the climate sensitivity distribution is distinct from the problem of trying to quantify tipping points. But yes, tipping points themselves, right, including them in the climate damage quantification is key. And when you do that, yep, your social cost once again increases, right? We get the plus 25 to 50%, which actually might be, depending on your prior, might not be all that high an increase, relatively speaking, right? But clearly ignoring them would not be the right answer either, right? So, sorry, go ahead, Rob.
Well, I was going to say we are actually just about out of time.
Yeah.
There are two more questions here, and I have one as well.
Okay, great.
Maybe the thing to do would be to call this. I mean, if you want a sort of a concluding comment or something, and then we can chat and talk about these questions in the next 15 minutes.
That sounds great. So I just switched to my very last slide, but happy to give you the conclusion I rehearsed, or I tried to. Let me actually. So this is a new graph. So let me start here. So grand conclusion, if there is one, is that yes, this time delay component matters, right? It decreases the social cost of carbon. It does so by around 30%, at least. That matters. Right? But it doesn't matter as much as the simple switch from constant relative risk aversion utility to Epstein-Zinn. If we do that, we open ourselves up to a much, much larger philosophical debate than maybe even the discount rate debate, which doesn't mean that it shouldn't happen, right? It may well be the right step. But for example, so this is now my version of this representation of this Epstein et al. Paper in AER a few years ago, right, where Epstein himself, of Epstein-Zinn fame, basically takes a step back and says, wait, there are some in some sense subtle but crucial thought experiments here that frankly go the other way, that that have conclusions that are so far out there that I, Epstein, do not believe that Epstein-Zinn preferences that or may not be the way to go here, right? Because they've raised so many flags that will not allow us here to call the move to Epstein-Zinn preferences, a solution to anything. For that matter, in our case here, right? Looking at this thought experiment of how much EIS matters to the social cost of carbon. Well, this little thought experiment here between current period consumption and levelized future consumption, we have no idea what the right EIS is here based on an experiment, a lab experiment, let's say, represented here. Meanwhile, yes, the difference between 0.69 and 1.5 matters so much that simply hiding behind somebody else giving us the EIS in our calibration is probably not the right way. We need to think a lot harder about what this EIS ought to be in the context that we're using it in order for us to conclude anything about the social cost of carbon. Right, so with that, I'm happy to go back to the prior graph, or maybe let me promote my books here. Yes, with that, right, so this is clearly work in progress, this DICE-EZ-RB paper. I don't quite yet know what to emphasize within this modeling exercise. At this point, essentially, it presents two crucial caveats to moving to EZ preferences on the one hand, integrating tipping points or tail risk on the other. We know both matter. We also know that, frankly, in either case, the social cost increases by quite a bit, right? So we won't get away with, right? The Biden administration is not going to get away with using a $40 per ton of CO2 social cost of carbon anymore. Unfortunately, the sort of unsatisfying conclusion here is that there just may not be a single other number we can use either, right? Rest assured, we will, right? In our legal proceedings, right, going forward, of course, we'll pick a number, right? But maybe, not just maybe, but most definitely, the right approach here is to insist on using a PDF, not the PDF Adobe gives us, but a probability density function around the social cost, which makes things more complex in applying it, but that complexity should be warranted in us moving forward on these crucial social cost of carbon calculations. So yeah, with that, happy to take any and all questions.
Thank you very much. I want to just ask a quick one first, and then I want to suggest that you look at the Q&A there, because there are a couple of questions there. You're discounting out to infinity, I suppose, in this calculation. I've always been amazed at how much of the damages are past the century mark. And so many times you see people just discounting out to 2100, which might be justified if you have a high discount rate, but not if you have a low discount rate. So
absolutely,
what you're telling us is that this EIS difference is probably stuff that happens, more than 100 years away. And there's a lot more uncertainty about that. I mean, there's no technical change allowed, no carbon sequestration technical breakthroughs that you can think of. So I wonder if there is a justification for ignoring things that are more than 100 years away on just that sort of ground. And I'm a little uneasy about it.
So there is not to be too philosophical here, but climate, it's just a really hard problem.
Yeah, right.
Right. There's no, so there's all these quotes out there, right? It's the mother of all externalities. It's the mother of all benefit cost analyses, and so, it is, right? It's like I teach a couple undergrad classes, or for that matter, at the Wagner School, master's level classes on this stuff, right? On climate economics 101 kind of thing. I spend a lot of time, basically, just talking about how difficult it is, and it is. It really is. It's not easy. There's a reason why, right? Climate economists have written a few hundred, 600 or so, peer-reviewed papers on the discounting question alone. A lot of duplicative work, of course, too, right? But there's just so many interesting questions here. Your time question, right? Crucial. And, in some sense, right, the big question, okay, the real question, right, sort of in some sense to, figure out what it practically matters is, okay, how does it actually influence the social cost today, right? So for example, Bill Nordhaus for the longest time basically cut off his model in 2350. Why 2350? I don't think there's a real reason for it, except that the stuff that happens further out just doesn't matter, and 2350 was a round number. Used to be 2300, now it's 2350, right? That's some sort of internal consistency. So it's a round number, right? And yeah, you got to cut it off at some point. You can't literally pretend to grow out a millennium, right? And then have such a low discount rate for everything to matter. On the other hand, yeah, most of this climate, right? As bad as it is right now, just to be clear, right? So, forest fires, all that sort of stuff, right? Quantified today. These things matter. They matter a lot. And by the way, there's a lot of interesting work being done there too. We're basically looking at, right? So you look at the climate damage function assumed in one of these major climate economy models, and then you compare it to just the damage of one hurricane in one particular year. And you see that the hurricane damage or the wildfire damage in that one year, just in the US, is larger than the assumed climate damages in this, right, macroeconomic climate economic model. Now, of course, you can't compare, this is not apples to apples, right? Because one is in expectations The other one is the, a bad draw in distribution. But of course, right? So it turns out we had, 3 bad draws in a row now in California with wildfires. We had, right, a few bad draws in a row with hurricanes. 100-year storms now happen every 5 years, 10 years, and so on, right? So at some point, the distribution, of course, changes dramatically too. And it's, that's the point. So of course, right? So I don't have to put on my environmentalist hat to argue strongly that we need to do a lot more on the climate front than we currently do. A very standard benefit cost analysis shows you all of that. Meanwhile, when you do look at tipping points, these preference calibrations, all this other stuff, and then, right, go out centuries with an appropriately low, what I would call appropriately low discount rate, suddenly the impetus to act today is even larger. Right now, we are not talking, this is sort of the German social cost of carbon story. They have 600 euros in some specifications, right? That is Green New Deal territory, just to be clear, right? This is basically saying that a massive, massive investment today is justified based on the benefit cost analysis, right? Forget the politics, forget inequality, all of this other stuff that ought to be included when we talk climate policy or economic policy in general. In this case, standard benefit cost analysis futs around with a few of the crucial parameters, and suddenly you get this very, very large social cost of carbon. And yes, social costs right above $100 would push us to significantly more action than we're currently willing to even contemplate.
Okay, so there are, I see 2 more questions here, and probably there are other people in the audience who'd like to ask questions. David Savage, do you want to ask yours?
Hi, can you hear me okay?
I can, yes.
So I'm wondering, I work primarily on biodiversity. I'm wondering if, like, how much you think the damage functions here are underestimating potential damages by avoiding things that are hard to quantify, like the economic value of damage to biodiversity.
Short answer, a lot, right? So, there's it might not seem very flippant, but the best answer is we quantify the quantifiables, right? Or in Don Rumsfeld speak, right? We quantify the known knowns. There are lots and lots of known unknowns, or for that matter, known knowns that we simply haven't gotten around to quantifying yet, right? And it's it's a huge problem. And of course, right, by definition, the more we quantify these damages, the more the urgency to act today. So there's some groups that they're doing, sort of God's work on this, the Climate Impacts Lab, right? Lots of us have been jumping up and down, basically saying somebody ought to do it. Well, Greenstone, Sheng, Kopp, and lots of others, dozens of postdocs, grad students working on this, are in fact going, right, sector by sector, quantifying climate damages. It's crucial, crucial work. And on the biodiversity front, I hate to say that, but we, for the most part, we haven't even started yet, right? We, the climate economic profession. So, of course, we all know that it ought to be quantified. Right? In some sense, much like the green GDP calculations, right? Green accounting. We've known since what, the 60s? I mean, Simon Kuznets himself told us that national income accounting is inappropriate as a welfare measure because it leaves out so much stuff, right? Kuznets said it. Leontiev said it. Dale Jorgensen has been saying it for decades. Bill Nordhaus has been on the National Academy Commission saying it for decades, right? The Bureau of Economic Analysis hasn't really been doing it, right? They started tentatively, tepidly, right, to sort of satellite accounts and so on. The quantification just takes a long time, and in some sense, what's the best conclusion we should draw right now is that whatever comes out of these social cost calculations is the bare minimum, right? It is often so laughably low that right, I don't know whether the right reaction is to just increase it by an order of magnitude or increase it by 50% and say that should be the minimum. Well, not really, right? That's, in legal terms, maybe, arbitrary, capricious, or whatever else the fancy legal terms are for that. But the stuff that does come out of these calculations is so low that, right, that's the bare, that's the lower bound here, right? We can't possibly go any lower than the $40 under Obama, or right by about now, I hope it would be 100 or more, and call that the lower bound, knowing that it excludes things like biodiversity in major ways.
So the next question is actually sort of on the other side of this question, whether maybe we're overestimating damages. Dinos Gonatas, do you want to ask your question?
Oh, go ahead. Actually, I can read it here, so happy to. And I realize we are already over time, so let me try. Let me try to read quickly. So, yes, and actually, I happen to have a slide here. So, nuclear, of course, is a very specific question here, but in some sense, this is what that paper tries to do and does, right? So the outcome here, why do we see these rapidly decreasing social cost of carbon figures? Well, risk and uncertainty drives it high today and drives the decrease. Another important factor in driving the decrease is technological progress, right? So of course, right, in the limit, if it didn't cost, if it cost $0 to suck out as much CO2 out of thin air as we could, right, climate would go away as a problem, of course, right? Now, even though there have been amazing increases, right, in technological, in energy efficiency technologies and so on, and decreases in the cost of decarbonization. All of these are important, right? Solar PV minus 90% in a decade, right? Sort of these amazing technological advances that nobody predicted only 10 years ago. It is, right, at least under sort of standard assumptions in many ways, still costly to decarbonize. And that cost will stay relatively high for long enough to want to have a high price per ton of CO2 to enable, to push this transition. The price alone is not enough, right? We need subsidies, we need regulation, we need lots of other things. But the climate problem by itself isn't going to go away, right, without climate policy. That said, right, in some sense, if 100 years from now, we're still sitting here on Zoom debating the right price per ton of CO2, we've lost this, right? 50, 100 years from now, we better, right, be so far along the way to rapid decarbonization, if not having decarbonized the global economy by, right, US Biden goal now 2050, China's goal 2060, net carbon neutral, that, yeah, by then, right, these alternative techs are so much cheaper that the carbon pricing conversation will, disappear automatically because, well, if you pick between clean and dirty, nobody wants to go back to dirty if the clean alternative is so much cheaper.
Well, I think we better bring this to a close, and we want to thank you so much, Gernot. This was very interesting, and it only kind of whets the appetite for all the things that need to be done going forward to really understand all the policy implications and all the damage functions that are missing, and what
lots of work to be done, that's for sure.
A lot of work to be done, and it's terribly important.
Thank you. Thanks, Rob. Thanks, everyone. And sorry I didn't get to every question. You know how to find me. Happy to try to take things offline, or I guess online, but outside this conversation. Thanks, everyone.
Thank you. Okay, bye.